sometimes even say circuits published in good quality books. For instance, this book, it's talking about the LM386, and that is a small audio amplifier, and it works very good in general, but anyway. And here you see the typical applications in this data book. Amplifier with a gain of 20, and here an amplifier with a gain of 200. So I made this circuit out of this data book, and I think the gain was so extremely high that it started to oscillate. And oscillation is always a problem. There are, say, kind of standard solutions to cure that. So here is my schematic. Compare it to the schematic in the book anyway. And I have by purpose used here a standard way of making that sensitive transistor circuit or a sensitive chip audio amplifier cannot oscillate, does not want to oscillate, by using here a 10 microfarad capacitor, 100K resistor and a 100 nanofarad capacitor. And in general that's more than enough to make such a chip. Doesn't have to be, by the way, an LM386, can be any other audio chip that can amplify between 1 watt and approximately 10 watt or even more works. So the whole setup is, in my opinion, quite good, but I found problems, and I had not expected that at all with the LM386. Of course, say kind of standard oscillation problems, too long wiring, wiring, signal is coupled from the amplified part of the amplifier to the very sensitive input part in one or another way. Could be via wiring, could even be via the chassis, that the signal is coming back and the whole amplifier starts to oscillate. Anyway, again, this circuit perhaps is interesting. I'm working on a project, and I'm at the moment not telling what that project will be about, but this is the test, not a test circuit, but in a certain way the definite circuit. Here it is. So now I give a voltage to it, and you hear that annoying sound on the background. It's 9 volts now here. Here is my oscilloscope that's connected to the loudspeaker, and you can surely see that there are oscillations in that circuit. When I touch it with my finger, that's also, say, a kind of indication that the earth connection is not okay. But in general, say, the whole setup, like I use this always in all my radio circuits and even audio circuits, this is a good setup. And my idea is that only the fact that I have set this LM386 to 200 times amplification gives this problem. And we have now at the input a 10K potentiometer that always has an effect because the input impedance on the 0.3 of the op-amp, the LM386 is in fact an op-amp. When the input impedance is low, no oscillation effects can be expected. That's, say, a kind of general rule. And also when the power supply is properly decoupled here, no oscillation effects can be expected. But the problem is that you hear now, say, an audio signal, audio sound, but on the background there is an enormous oscillation going on a much higher frequency. And that's a classical problem of, say, chip audio amplifiers, and then especially chip audio amplifiers of the past, say approximately 10 years ago. And the manufacturers of audio chips have learned their lesson in a certain way and made all these chips less sensitive for oscillations. I switch off now the power supply. Let's see what happens. So the signal of my sine wave oscillator is extremely annoying. I don't like it, but it's necessary for demo purposes. Anyway, well, is there a cure for such a parasitic? In fact, it's a parasitic oscillation. Yes, there are cures. Absolutely sure. So, like I told, in general, making the input impedance, and in fact that is the input resistance in this case, lower. Use a good decoupling unit here. This is also important. There is a so-called Zobel network here. And in the book, I have to put the camera down for a while and look again at the data book of National Semiconductors. I have to find the page for the LM386. That's page 1055. So there are many, say, very easy chips that you can use everywhere. Here is the datasheet again. National Semiconductors, and perhaps I have to switch to the amplification amplifier with a gain of 20. Perhaps that's a good idea, and then use a preamp. Perhaps in that case the whole circuit will not oscillate. Say, that's a kind of first side solution. But I'm now working and testing this circuit. Anyway, well, here are of course all the other properties you can buy or find these, say, this important information everywhere on the World Wide Web, and I only pen over somewhat. Again, amplifier with gain of 50, that could be another solution here. I think I'm gonna use that. Amplifier gain with gain of 50, and here a low distortion power and power Wien bridge oscillator. Well, that's also a very interesting application. You can use this chip to make sine waves in a more or less classical way. And when I say classical way, they use here a very small lamp to limit the amplitude. And of course there are here, say in this circuit, factors of resistance and capacitance, and well, I'm absolutely sure that here it is set to a certain sine wave frequency, but anyway, changing that RC values will change the output frequency. This is also interesting. Amplifier with bass boost. So I started quite negative about this chip, but finally it's a little bit positive. Square wave oscillator with that chip anyway. I'm absolutely not sure, absolutely convinced that my power supply is completely okay, and there is a kind of flaw in the circuit in this National Semiconductors book, but of course it doesn't have to be a serious flaw. Perhaps they tested in a laboratory situation with all kinds of ideal circumstances, and the setting that chip to 200 times amplification worked okay. But I think I'm gonna adapt this circuit somewhat, take it to approximately 50 times amplification and use a pre-amplifier. Thanks for watching. More or less all to tell. Let's listen and look at the scope again. This is very, very bad. So, when you say this, you can surely see that the amplification is far too high. That means that sine waves are changed into square waves. And that's happening here. Anyway, had not expected that this universal and good quality chip could lead to say this issue, but it can surely be solved, and I'm surely going to solve the problem. Again, thanks for watching.